Hello math people, this is Mr. McAllen, and today we're going to work on finding increasing and decreasing intervals, and we're going to use some derivative testing to do this. So the first thing is we're going to look at the function that we have given to us. It says to find its extreme values and any intervals where the function is increasing and decreasing. So going back to the idea of finding extreme values, that's where you find your critical points by setting your derivative equal to 0 or finding out where it does not exist. And then using those values, you plug them back into the function to see what the extreme values were. For example, we're going to see if our graph has any locations where the derivative equals 0 or doesn't exist. We're going to plug those critical values back into the function using a table and identify what the critical values are. Remember, the critical values are the values of the function. So let's start off with this function, and I'll take the derivative. And remember, when we look at this function, we've got a little bit of a chain rule going on. If you wanted to square the binomial, FOIL it out, and find out the polynomial, you could, but I'd rather use the chain rule. So I have 2 times x squared minus 4 to the first power times 2x from the derivative of the inner function. I'm going to set that equal to 0. So I have this 4x, I'll bring the 4x term up in front, x squared minus 4. I'm going to continue to factor my terms so I get all the zeros, and you can see from setting each term individually equal to 0 that I get all of my critical points. So my first critical point is going to be at 0, my second critical point is going to be at -2, and my third critical point is going to be at 2. I'm going to put that on a table because the very first part of the question was to find the extreme value. So I want to find that first. So I'm going to put this on a table, x, and my function value. Now remember, this is not your derivative value for this part, this is your function value. So I'm going to put that on there, and I'm going to plug in -2, 0, and 2 into the original function. And the original function was x squared minus 4, that quantity squared. So when I put -2 into there, I have -2 squared. Let me make this neater. I'll change the ink so you can see it better. -2 squared minus 4, that whole quantity squared, that is going to end up being 0. The next one, when I put 0 in, I end up having just -4 squared, which will get me 16. That's the extreme value at that point of 0. And the last one, when I put 2 in, I'll have 2 squared minus 4. That whole quantity squared is also going to give me 0. So my extreme values of the function are 0 and 16. Now let's find out when the function was increasing and decreasing. So what we do for this case is we make a number line for our derivative values. So this is f prime, and underneath I'm going to put the critical values. So I have -2, 0, and 2, and I'm going to put a 0 above because these critical values, my derivative was 0 at them. Now I'm just going to interval test. The derivative that I'm interval testing is a nice easy function. It's got this 4x, x plus 2, x minus 2. I'm going to plug in a test point. So my test point for this interval, let's say it's -3. So when I plug in -3, I'm going to get negative, negative, and negative. So that's going to make a negative times a negative times a negative. It could be a negative. Oop, I did positive, that's a negative. Then my next point is going to be, it could be -1, so it'll be negative again. So I'll put -1 here. Be -1, and then this will be positive, and then this will be negative. So that'll result in a positive. So right now, I know that my function f of x is decreasing. Now it's increasing. I'm going to plug 1 in. And when I plug 1 in, I'll get positive, positive, negative. That'll make a negative there. So now it's decreasing in this interval. And the last part is I have from 2 to infinity, I'll pick 3. If I pick 3, I'll get positive, positive, and positive. And that will be an increasing interval. So the way you want to write out the statement correctly, so you get full credit, you have to justify your statement. You say f of x is increasing on the interval from -2 to 0 and 2 to infinity because f prime of x is positive. And the second part, f of x is decreasing on the interval from negative infinity, this interval here, negative infinity to -2, and from 0 to 2 because f prime of x is negative. This is plenty to justify your answers for increasing and decreasing. You're using the number line, the first derivative test, and stating that based on the first derivative, you know whether the function is going up or down. That's all you need to do to answer the questions for this problem. But let's just draw a picture to show what was happening. We have a value at -2, we were at 0. At 0, we were at 16. And at 2, we were at 0 again. And because the function said it was decreasing, had a derivative of 0, and then increased, the function does something like this. And if you plot that on Desmos, you will clearly see that the function x squared minus 4 squared looks something like this graph. Hopefully this video has helped you understand how to find increasing and decreasing intervals and also extreme values. Thanks for your, I look forward to hearing your comments, and thanks for your input.